Hello everyone and welcome back to Pinnacle Academy. I'm Sannel Patel, Director of Business Development and Marketing at Pinnacle Ozone and a chemical engineer. Today's session is focused on something that sits at the core of every ozone system. It's understanding ozone formulas, conversions, and system design. It's about chemistry, physics, and most important, applied engineering math. And if you understand the math, you understand the system. So let's talk about why calculations matter. Before we get into the equations, let's take a step back. Let's understand, why do ozone calculations actually matter? Every ozone system, regardless of the applications, comes down to four core variables: water flow rate, the dose, the ozone output, and the mass transfer efficiency. These define everything from system sizing, performance, energy consumption, and ultimately whether the system works or not. If you get these wrong, you either undersize the system and fail at performance, or you oversize the system and then you have waste of capital and energy. So let's break it down even further. The core variables. From an engineering perspective, there are basically four main variables. You have the flow rate, which is your hydraulic loading. Typically, this is measured in gallons per minute or meter cube per hour or liters per minute. Then you have dose, which is the amount of ozone applied per volume, which is normally measured in milligram per liter. You have the ozone output, which is what the ozone generator must produce or produces, which is in grams per hour or pounds per day. At the end, you get the efficiency. Efficiency tells you how much ozone actually is dissolved into the water or used in your application. And all of these four are not independent. They are all linked together, and that's what the system is designed for, and that's the relationship what drives the system design. So let's talk about the fundamental equations. At the core of the ozone system, there's two fundamental equations. You have dose, which is equal to mass divided by flow, or you have mass, which is equal to dose multiplied by flow. So it's basically one equation with variables moved around. This is the foundation of everything. If you know your required dose and your system flow rate, you can calculate the ozone mass required. From there, you size your ozone generator, you design your injection system, and then you can validate performance. This is not theoretical. This is what we use every day in a real life system design. Let's talk about unit consistency. This is where most of the mistakes actually happen. When we talk about flow, we're talking about gallons per minute, meter cube per hour, or liters per minute. When you're talking about ozone output, you're talking about grams per hour or pounds per day. When we're talking about concentration, it's milligrams per liter or ppm or percent by weight. You have to make sure that all your units are aligned. If your units are not aligned, your calculations are wrong. Now let's talk about one of the most important points of designing an ozone system. It's most often misunderstood. This is the mass transfer efficiency, known as eta. Eta is the dissolved ozone divided by the generated ozone. Typical systems operate between 20 to 95% efficiency, but this depends highly on injection method, mixing conditions, contact time, and most important, the water quality. This is critical because if you don't size a generator based on dose alone, you get a system that doesn't perform to your standards. And if you have to design it for a system based on dose and efficiency. If your efficiency is low, your generator needs to work harder, your energy costs will increase, and your performance suffers. So therefore, it is very critical to understand, yes, you have an ozone system, what is the mass transfer efficiency? If it's a 70, you need to compensate for that remaining 30%. So now that we've talked about the theoretical aspect, let's go into more of the practical. We have some calculators on the Pinnacle Ozone website, and I'm going to go through these websites and show you how you can utilize these. I'll explain each of those formulas. Therefore, you have a better understanding on calculating ozone, how much ozone is required for projects, and where you can get these values. So let's start with the most fundamental one, the water ozone dosage calculator. This is where most designs actually begin. Over here, you'll have to input your flow rate, your dosage, and then that will give you the amount of ozone that's required. This is, once again, as I said, it's one of our core fundamental equations. It's important because this gives you a theoretical demand, not on the ozone generator, but this will help you to understand, hey, how much ozone is required. And then obviously you need to take the efficiency into consideration. So let's go here and give you an example. Let's say we have an application that was at 200 GPM or 200 gallons per minute, and we're doing a supply of 2 ppm. As soon as you input these two values, you get an ozone requirement of 90.72 grams per hour. If we say that we have a 90% efficiency of a system for this type of application, you then may want to size an ozone system 100 to 120 grams per hour to compensate for the efficiency, but also so that your system doesn't run at 100% at all times. My recommendation would be going slightly bigger than that. Therefore, you can run between the sweet spot of an ozone generator, which is normally between 70 to 80%. Let's look at our second calculator. So it's the ozone generator output calculator. This basically measures the ozone output based on the flow rate and concentration of your ozone generator. One thing that we need to make sure is this an oxygen stream or is this a dry air stream? So this is high concentration ozone or high concentration oxygen and lower concentration of oxygen. So if you go to the first tab, you'll see these two different selections. Oxygen feed gas, which is your feed gas is typically from a PSA unit or a LOX unit. Or you have dry air gas, which is very rare these days, but still available where you're taking atmospheric air and running that through a dryer and then directly into an ozone generator. So for this example, what I'll do is I'll recommend using the oxygen feed gas. Let's say we have a system that's going to be running 50 liters per minute of oxygen through the ozone generator. We know Pinnacle ozone generators like to work around the 8 to 12% range. So let's say it's a 10% ozone by weight that it's generating. Therefore, your ozone generator is going to be producing 429 grams per hour of ozone. This helps with understanding I have this flow of oxygen or I have this supply of oxygen. This is my percentage of ozone. I'm making about this grams per hour. You can then take this and see if it's going to work for your application based off the first calculator that we did. Moving on to our third calculator that we have, this is the ozone output unit converter. So a lot of times people are working with different type of units. As we said, units are extremely important. So if you're speaking to someone who's speaking in pounds per day and you have a gram per hour number, what would you do to calculate this? So an example, we've been using that number. We found out, hey, it's 429 grams per hour that's going to be needed. And you want to figure out how much pounds per day that is. You basically put your 429 grams per hour in, and the number that's right out there is pounds per day, 22.69 pounds per day that is being used or produced by the ozone generators. Once again, you're not doing any math here in terms of figuring out how much ozone is being created. You already have the grams per hour. What this is doing is helping you convert the grams per hour into pounds per day. Going on to our calculator number 4 here, which is the ozone concentration in oxygen. It's basically converting how much percent by weight you will have of oxygen. So this tool is basically meant for any time of oxygen feed systems, as is in the description here. So we normally work in percentage by weight. You would put your percentage, as I said, 10% by weight. That's what percentage of Pinnacle ozone system roughly makes. So that percentage by weight, if you want to figure out how much ppm is being produced, so once again, this is concentration, is going to produce 65,200 ppm at a 10% by weight. So concentration, both of them are concentrations. All right, now that you know the 4 main calculators, what I want to take your mind to and actually show you is this actual resource that we have. It's an ozone formula and conversions that are very important. I highly recommend going through all of these. What I'll do in this is I'll help you guys understand what each of these are. So once again, I told you about milligram per liter. This is what is used to dissolve in water. You have the grams per cubic meter. This is the standard measurement of ozone in a concentration in a gas stream. You have ppm, which is parts per million. You have the percentage by weight, which is normally the amount of concentration of ozone being produced. You have your different flow rate units. You have your liters per minute, you have your SCFM, meter cube per hour, or you have your gallons per minute. All of these can be used. I highly recommend sticking to one when talking about your calculations, so therefore you can keep all your units the same. And then finally, you come to the ozone generator. Most of the time we talk about grams per hour or pounds per day. Each of these two are important to know because they both have different scales, but it's good to know that grams per hour is used mostly here in the United States. And if you're overseas, a lot of the time pounds per day is used as well. What we've done is we've actually used this to help break down each of those formulas. So if you wanted to go ahead and do them yourself, you can use these calculations. So for grams per hour, it's flow rate times 60 times the dosage divided by 1,000. Very simple calculation, but that tells you the amount of ozone output per day or per hour that you'd be using. With your flow rate for ozone usage, it's the same thing. You have your required O3, which is equal to your flow rate, multiplied by a few conversions, which is 3.785, which is gallons to liters, or liters to gallons. You have your 60, which is your time differential, your dosage, and then you divide by 1,000. This is normally from grams to milligram conversion. The next one is your ozone concentration. So you have different numbers. One thing that is very critical to know is what is your feed gas. If your feed gas is air, you would use the top section for understanding the amount of ozone required. And if your feed gas is oxygen, you would then use the bottom section here. Okay, and this basically tells you the amount of ozone that's required or the amount of ozone that's being made with that oxygen stream. And then finally, a lot of times people are talking about milligrams per liter or ppm. It's a 1-to-1 ratio, so therefore you should just know your units that you're using. But it's good to know that the milligram per liter and ppm are similar words that are used, but it's the same value in terms of 1 milligram per liter is equal to 1 ppm. So ozone systems sit at an intersection point of between three core principles. You have physics, chemistry, and math. Let's look at it from the chemistry standpoint. Ozone is a strong oxidant. It's what drives the disinfection and breaking down of contaminants. You have the physics standpoint, which is it's all about the gas to liquid transfer. How efficiently are we getting the gas into the water? And then from the math standpoint, we qualify everything based on dose, mass, flow, and efficiency. If you don't understand all three, you cannot properly design and optimize an ozone system. At the end of the day, ozone design is not guesswork. It's structured, it's quantifiable, and it's driven by engineering fundamentals. If you understand flow, dose, mass, and efficiency, you can design, troubleshoot, and optimize any ozone system. If you'd like to explore these tools, please visit pinnacleozonsolutions.com and access all the ozone calculators and resources. Thank you again for visiting Pinnacle Academy, and we'll see you next time. Thank you.